Hey, let's consider the following two-body problem. A 30-gram hanging mass M2 is attached to 400-gram air track glider M1. Determine the acceleration of the system and the tension in the string. The rope doesn't stretch. There are two ways to solve this problem. While watching this video, you will learn both. The first way is by writing a free body diagram for each of the objects. One thing to mention, if we release the system, mass 2 will move downwards and pull the mass 1 to the right. The rope doesn't stretch, which means that the force of tension will be the same at any point on the string and the acceleration of two objects will be the same. First, let's set up a coordinate system. This one seems the most convenient. The x-axis is directed to the right and the y-axis is directed downwards. Let's draw a free body diagram for this object. Force of gravity is acting on it and is directed downwards. The normal force, table's reactive force, is directed upwards. Force of tension, Ft, pulls the mass 1 to the right. Now let's write Newton's second law for this object. Acceleration of mass 1 is equal to net force over m1. We write the projections of this force to the corresponding axis. For x-axis, we have acceleration A is equal to force of tension over m1. And now, for the y-axis, the mass 1 isn't moving on the y-axis, so there is no acceleration. We have 0 equals to force of gravity, m1g, minus normal force over m1. Let's do the same for the mass 2. There is no acceleration and forces acting on the x-axis, so that we can ignore the x-axis. For y-axis, we have acceleration is equal to force of gravity m2g minus force of tension over m2. So we have a system of equations. Let's rewrite them. Now, time to solve it. Let's equate two expressions for acceleration and solve for the force of tension. After some mathematical operations, we conclude that the force of tension equals the force of gravity m2g multiplied by m1 over m1 plus m2. We substitute the numerical values and get the force of tension equals 0.27 newtons. If we substitute this value to the equation 1, we get acceleration equals to 0.68 meters per second squared. Now, let's go to the second method. In this case, we solve the two-body problem as one-body problem. I.e., we take two bodies with masses m1 and m2 and consider it as one body of mass m1 plus m2. We ignore interactions happening between m1 and m2. Now we need to answer two questions. What forces move the object and what forces resist the movement? We can see that only force of gravity m2g moves our object, and there is no forces resisting the motion. So we write down Newton's equation of motion as follows. Acceleration is equal to net force over m1 plus m2. The net force, in this case, equals the force of gravity m2g because there is no resisting force. We substitute numerical values and get acceleration equal to 0.68 meters per second squared. So we get the same answer. Thank you for your attention. See you next time.